Okay, we're going to look at the second type of improper integrals. Remember from the beginning I said there were two major types. The first involved bounds that went to infinity, and we looked at two types of those, or two examples of those. Now we're going to look at the second type. And the second type, what happens here is our function is no longer continuous on the entire interval between a and b. And specifically for us, we're going to deal with discontinuities that appear strictly at the endpoints. What I mean by that is, if we look at the integral from a to b of f of x with respect to x, and we have a discontinuity at x equal to a, then we're going to rewrite this as a limit as c approaches a from the right of the integral from c to b of f of x with respect to x. If instead the discontinuity occurs at b, we're going to write this as the limit as c approaches b from the left of the integral from a to c of f of x with respect to x. Now this may seem a little bit much, and I know sometimes these notations tend to be a bit much, but one thing that you can remember is this. What we're going to do is we're going to replace the discontinuity with c. So when a is the problem, we'll put the c at the bottom. When b is the problem, we'll put the c on the top. And then we're going to approach whatever the bad value is, either from the left or the right. And what happens is we have to approach it from the inside the interval. So if you draw a picture and you think about that interval running between a and b, if a is the problem and I must approach a from the inside, then the only way I can do that is if I come at it from the right. So we'll look at the limit as we approach a from the right. If instead b is the problem and I have to come from the inside of the interval, notice that I would have to approach b from the left. So it gives us a little bit less to have to remember here. And I'll show you as we go through some examples that it's not necessary that you remember the formulas as they sit exactly, but just kind of understand how it works. And it's going to be real easy to remember what to do here. Now we will have to take some one-sided limits. And so just a quick reminder on how that works. Anytime we have a one-sided limit, we're going to try direct substitution first. And if that doesn't work, because if we try direct substitution and we get an invalid value, then what we'll do is try a numeric value. That means picking a value really close to what we need it to be, either from the left or the right, depending on what our instructions say. Well, a lot to look at, but let's just go through some examples and see how that works. Now, these types of improper integrals are a little bit harder to see because notice we don't have any bounds at infinity, but what we have here is a problem because this particular function is not going to be continuous at x equal to 0. So if you look at my interval here, I'm going between 0 and 1, and the problem is the 0. Now, if I need to come from inside the interval, that means I'm going to have to approach it from that way. So this will then become the limit as c approaches, and what we're going to do is we're going to approach that 0 from the right because that's the only way we can get to it, and then we're going to replace that 0 with a c. And then we'll just do our regular integration, 1 over the square root of x dx. So again, I really didn't memorize the formula. What I said is, okay, this is the problem. This is going to be the c, and I'm going to have to come at it from inside the interval, so I'm going to have to come at it from the right. And then again, we have a three-part integration to do. We've got a three-part problem to do. We're going to do the integration first, then we're going to put in the bounds, and then we're going to take that limit. So now before I do this integration, let me do a quick rewrite on this because this really is just a basic rule. As a matter of fact, I can rewrite this as x to the negative 1/2 with respect to x. And so again, I'm going to do the integration first. Notice in my notation that I don't get rid of the limit until I actually have the opportunity to do it. Let me go ahead and do the integration. When I integrate x to the negative 1/2, I'm going to get x to the positive 1/2 over a positive 1/2, which I will then look at between c and 1. Now, you may want to go ahead and flip that 1/2 and make it a 2, and you can actually bring that 2 all the way to the outside, and we don't need to leave it here. We can bring it all the way to the outside. This will become 2 times the limit as c approaches 0 from the right, and then the only thing I have left to deal with is the square root of x, which I'm going to look at between 1 and c, and remember it's going to be the top bound, which is the square root of 1, minus the bottom bound, which is going to be the square root of c. Now, if you need to split this up into two separate, let me get myself up here. This is going to be 2 times the limit as c approaches 0 from the right of the square root of 1 minus the limit as c approaches 0 from the right of the square root of c. Now, the limit as c approaches 0 from the right of square root of 1 is still going to just give me the square root of 1. That's easy enough. And here, as I said before, even when we have a one-sided limit, the first thing we try to do is a direct substitution. And in doing the direct substitution, I just simply get the square root of 0. So this is going to be square root of 1, which is 1 minus 0, or 2 times 1, which is 2. So we see that this particular integral does converge to a value of 2. Let's go ahead and look at our next example. Again, these improper integrals are much harder to see because I don't see infinite bounds. But what I do notice is that 5 is the problem here. Because if I try to put in a value of 5, that gives me a 0 in that denominator. And remember, we're looking at the interval between 0 and 5. 5 is the problem, so I'm going to turn that into a c, and the only way I can approach it is coming in from this side. So I'm going to rewrite this as the limit as c approaches 5 from the left of the integral from 0 to c, and let me rewrite that integral as simply a 5 minus x raised to the negative 3/2 power with respect to x. So again, it's not that I'm memorizing a whole bunch of things in here. I'm just replacing the problem with a c and then approaching it from the right direction. Now again, we have 3 separate pieces to do. We're going to start by doing the integration. This is going to involve a u substitution. U here is going to be 5 minus x, which means the u prime is a negative 1. I will need a negative 1 on the inside of here. No problem. There's my u prime anyway. This is the u to the negative 3/2. I'm going to put that negative, and I'm going to bring it all the way outside in front of the limit, because you can do that. You could put the negative 1 here, but you could also bring that all the way out in front of the limit as well. So this then gives me minus the limit as c approaches 5 from the left. When we integrate u prime times u to the negative 3/2, we're going to get u to the negative 1/2, and I'll leave that as a negative 1/2 right now, over a negative 1/2. Of course, remember, we're still going to have to put in our bounds at some point. Let me go ahead and kind of fix things up a little bit here. First off, this negative 1/2 is going to flip and multiply as a negative 2. And I'm going to take that negative 2 and I'm going to bring it out here and combine it with this negative. So I'm going to get 2 times the limit as c approaches 5 from the left. This u is going to have to come down to the bottom, and I am going to get 1 divided by the square root of u. U in this case was 5 minus x, which I will look at between 0 and c. Now, remember that we need to come in here and put in the bounds, and the bounds have to go into the entire function, and this thing is the entire function. So this becomes 2 times the limit as c approaches 5 from the left of the following. 1 divided by the square root of 5 minus c, putting in the upper bound, minus 1 divided by the square root of 5 minus 0, putting in the lower bound. Again, you can rewrite this as 2 separate limits. Make sure you multiply the 2 by both. So this is going to be 2 times the limit as c approaches 5 from the left of 1 over the square root of 5 minus c, minus the limit as c approaches 5 from the left of 1 over the square root of 5. And of course, notice here there's no c. So this value is just 1 over the square root of 5. And so the only problem we see is in this one. Now I'm going to kind of go past my notes here, and I'll come back and talk to you about those notes in a minute. But I'm just going to keep working down my page since I kind of ran myself out of room here. If I try to do a direct substitution, now I'm just looking at this limit because I've taken care of this. Matter of fact, if you want, we can rewrite this as 2 times the limit as c approaches 5 from the left of 1 over the square root of 5 minus c minus 1 over the square root of 5, because we've taken care of that second limit. Now we look here, and if I try to put in a 5, that's going to put 0 in the denominator, and I am not allowed to do that. So a direct substitution is not going to work. Well, what do we have to do instead? Well, what we're going to do is we're going to come in to the number 5, and this is how one-sided limits do work. We're going to do this numerically. We're going to approach 5 from the left, which means we're coming in from this direction. And I'm going to pick a value that's super, super close to 5 from this direction. For example, 4.99999. And I'm going to then take that value and plug it in here. So I get 2. Now I'm evaluating the limit by putting that in. So I'm going to have 1 over the square root of 5 minus 4.9999, sorry about that little mark there, minus 1 over the square root of 5. And let's see what happens to this. This number basically gets very, very close to 0. It's a super, super tiny number. And when we take any number and divide it by a super, super tiny number, that number goes to infinity. And 2 times infinity minus a number is going to give us infinity. Therefore, this particular integral diverges to infinity. If you need a review on one-sided limits, there is an optional video which will appear in your Canvas course that you can watch that goes over those one-sided limits in a little more detail.